Hello, my name is John Davis. I'm the Chief Product Officer at Bigstream Solutions. We're excited to be here at XDF to show our F1 solution running big data applications on FPGAs. I'll go through some of the slides that give us an overview of how our system works with zero code change, giving you instant acceleration on your big data applications like what you would run in Apache Spark. So our application basically provides addressing the problem of looking at how do we accelerate big data applications. Generally we have these large big data platforms like Apache Spark where data scientists try to describe their application in a high-level language, which is very great, but it doesn't give them the capability to look at the low level and understand the actual performance or underlying components. We also have performance engineers on the other side that understand how to make FPGAs fast, but they don't understand the high-level applications on their primitives for, say, a risk model or those types of things. We're addressing both of those points. If you look at our solution, we basically layer underneath big data platforms like Apache Spark. We have 3 layers: an adaptation layer, a hypervisor layer, and a data flow layer. And this slices and dices the computation seamlessly, effortlessly. So from that perspective, your data scientists use the same application, zero code change, and we make it run faster on these different platforms, including the new Xilinx FPGAs. So when we look at the F1 instance, we're taking a TPC-DS application. We're just taking the stock program. We're adding our special sauce to it to enable the FPGA. That gives us anywhere from 3 to 4x speed up when we compare the same FPGA versus a CPU on that instance, the F1 instance. For the demo, we're going to do a side-by-side comparison showing you the running of the F1 instance with an FPGA enabled versus just the CPU, and you'll see as the screen scrolls by the rapid improvement in terms of just throughput for the system. And at the end, you can look at end-to-end times. Fundamentally, the most important thing for us is end-to-end acceleration versus particular stage acceleration. So what we have here on the left is a screen into an F1 instance. What we're going to be running there is just plain vanilla Spark. We have some Spark submit command that does the initial Spark submit. We'll let that run fast first in order to start that process. And then what we have on the right is the same Spark application here, but here we've enabled our acceleration. And you'll see that start up as well. If I can start it, there we go. And so we go through the whole initial compilation phase. We've given the software side a head start, but as you'll see, it will rapidly speed up and go much faster. As you're watching the screen go by, some of the colored text actually shows you that the FPGA has been enabled after we've done a bunch of the compilation and real-time acceleration. Here's the acceleration from the FPGA side being enabled on the F1 instance. And as you can see, the instances, these tasks that are going much faster compared to the other one. And once we get to the end of this and we look at the run end-to-end time, you'd see over a 4x improvement in overall runtime. All right, so eventually this one will finish. It's going to take about 95 seconds. Here you can see the end-to-end time was 22.8 seconds. So if we take that 95 seconds and we divide it by 22.8, we get a speed up of almost 4.2x. So those are the types of performance numbers we're getting in the initial ramp up version of our F1 instance versus the same CPU instance.